It's 10 degrees outside, and I don't have any power, but my laptop runs on batteries, and so that means that today we can still talk about factoring trinomials. Wow, factoring not trinomials. Okay, there we go. Factoring trinomials. Specifically, when the leading coefficient is 1, but that's kind of its own deal. So, here's something that you've seen in the past, or at least you should have. Something like this, x plus 3 and x plus 2. Sure. How would you multiply these two things together? Well, hopefully you would remember that we're distributing this first term to the second term, and so that means we need to multiply x times x and get x squared. We need to multiply x times 2 and get, or really, I mean, it's really more like we need to also multiply 3 times x, so we get 3x. We multiply x times 2 and we get 2x, and then we multiply 3 times 2 and we get 6. So then the answer would be x squared plus 5x plus 6. So that's what happens when we multiply, but now factoring, just like division is the opposite of multiplication, or subtraction is the opposite of addition, factoring is the opposite of distributing. Okay? So what if I were to give you a problem like this, where we have, get it in red, x squared plus 7x plus 10. What would you do with that? Well, we're looking, since we kind of know this general structure, right? I know that I'll have an x, I'll have two terms. I'll have an x and an x, because x times x is x squared. And then I need two other numbers, right? And now since these are both positive, I know that these are both positive. So I'm thinking over here, 3 times 2 was 6, so I need two numbers that multiply to 10. And then 3 plus 2 is 5x, so I also need two numbers that add to 7. Well, what are some numbers that multiply to 10? Well, we've got 10 and 1, and then we've got 5 and 2, and as far as whole numbers go, at least, that's really all we've got. 10 plus 1 is 11, so that's not good, but 5 plus 2 is 7. So here, if I put a 5 here and a 2 here, then I would have successfully factored out x squared plus 7x plus 10. Now you could check this by doing what we did over here and multiplying it out. So let's see, maybe we can check in blue. So check. X plus 5 times x plus 2. If you were to distribute, right, x times x, x times 2. So x squared plus 2x plus 5x plus 10. That's x squared plus 7x plus 10, which is right? That's what we got up here. So it means we factored that out correctly. Okay, let me throw another one at you. What if I had something like this? X squared, whoa, not sure. I think I'd like to change colors. X squared plus, or rather minus 6x plus 8. Okay, so again, I know if I'm down here, I have my x and I have my x. Now the question is, I need two numbers that multiply to positive 8. And I need two numbers that add to negative 6. Okay, so because I need to fill in the blanks here, right? With two numbers that multiply to 8 and add to negative 6. So I always start and say, what multiplies to positive 8? Well, something that multiplies to 8 is 1 times 8. What else multiplies to 8? 4 times 2. And then that's all I can think of as far as two numbers go that multiply to 8. 1 plus 8 is 9, but 4 plus 2 is positive 6. Now, is there a way I could get that to be negative 6? Well, what if instead of positive 4 and positive 2, I had negative 4 and negative 2? A negative times a negative is a positive, so that would work here. And a negative plus a negative is negative 6. So I would have x minus 4 and x minus 2. And again, you could check that by multiplying that out, but you'll find that when we multiply out what we just factored, you'll get x plus 4 times x minus 2. Okay, one more scenario for you here. And maybe we can try this. X squared minus x plus, minus 12. Okay, so it's the same idea, right? I know that because I have x squared right here, I know that I'm going to have an x here and an x here. And now I'm just looking for two numbers that multiply to negative 12 and that add to negative x, that's like negative 1x, right? So they add to negative 1. So what are some numbers? I always think, what are numbers that multiply to 12? Well, we have 1 and 12, we have 6 and 2, and we have 3 and 4. And I think that's just about it, as far as whole numbers go, at least. So these numbers need to add to negative 1. So if they multiply to negative 12, well, then either I have negative 1 and positive 12, or I have negative 12 and positive 1. So the numbers I'm looking for need to add to negative 1. Well, negative 1 plus 12 is negative 11. Is positive 11. Negative 12 plus 1 is negative 11. Negative 6 plus 2 is negative 4. 6 plus negative 2 is positive 4. Negative 3 plus 4 is 1. 3 plus negative 4 is negative 1. So then the two numbers that add would be positive 3 plus negative 4. So if I'm adding to negative 1, I'm really just looking for numbers that are 1 apart. So now over here, I have positive 3 and negative 4, so this would be x plus 3 and x minus 4, and that would be my answer. And maybe this one is worth checking a little bit more in depth. So if I were to check it, right, x plus 3 times x minus 4. X times x is x squared. I'll write it in blue still. X times negative 4 is minus 4x. 3 times x is 3x. And 3 times negative 4 is negative 12. Combine negative 4x plus 3x is negative x minus 12. And that was my answer, right? Or that was my problem that I started with. So it all checks out. Okay, so those are some different ways that you'll see factoring when you don't have, when your leading coefficient, we might say, is 1. When we just have one x squared here, we don't have multiple x squareds. We'll talk about what happens when we have numbers in front of that in a future video.